All right, so you should be wearing your earbuds for this introduction to the periodic table. We're going to be looking at how the periodic table is organized, and then you guys are going to go and roam around the classroom and investigate properties of each group. All right, so first, the history of the periodic table. This crazy looking dude right here is a Russian chemist named Dmitry Mendeleev. All right, say his last name, please. Mendeleev. All right, he arranged the elements in order of increasing atomic mass. All right, remember that all the mass of an atom can be found in the nucleus. And he was, at the time, unaware of several atoms that had yet to be discovered, but he believed that their presence existed. And so his periodic table, imagine if you will, putting down element names and atomic masses on note cards, and then arranging them in such a way. And he left holes or gaps of certain elements that he believed to be present. So if you'll notice on this, slide, those that were known to Mendeleev are this taupe color, and those that were unknown to him are highlighted in blue. All right. So he left holes, actually, if you look in the middle, all right, for scandium, for gallium, for germanium, and they were discovered after, I don't know the exact times when they were discovered, but after his death, I guess. I just made that up. I don't really know the answer to that. But anyhow, they were discovered later on after Mendeleev left the giant holes. All right. So there are many others that he left holes for too. The noble gases in particular, if you will notice on the left for you, that would be the left column there. All right. All right. Next. Now, the modern periodic table was rearranged because if you look at the atomic masses, right, as we began to investigate and become more aware of isotopes and the various masses, it got to be a little bit of a headache to try to arrange them. So, George Moseley rearranged the periodic table in order of increasing atomic number. Now, we know that the atomic number is the fancy blue number that we see on Miss Freeman's periodic table. Those atomic numbers were assigned based on the number of protons. All right, so it's not Moses, it's George Moseley who arranged them in order of increasing atomic number. All right, so that's our modern periodic table. All right. Now, groups. You're already familiar with this idea of a group being a vertical column. Now, groups are called families. So just like you and your family members have similarities, maybe you have similar characteristics, maybe you and your mom are both left-handed, you have similar properties. Now, the way that these elements in these columns are grouped is because they have the same number of valence electrons. So you'll remember back to our blowing up the bathtubs. Everybody in group 1A are called the alkali metals, and they have one valence electron. So we're going to be looking at different patterns that begin to emerge as we move from top to bottom in a group. All right, so you'll notice here that the D block and the F block are not included in my group names. All right, these don't follow the general patterns or trends, so we exclude them from our group descriptions. Okay, all right. Now, a period, just like the period comes at the end of a sentence, which is written horizontally, a period, you would call it a row, but you already know that it corresponds to the energy levels. You see on Miss Freeman's periodic table that it's represented by the letter N. And just like we notice patterns that begin to emerge in groups, we see the same trends emerging in periods or rows as we move from left to right of the periodic table. Now, these patterns or trends are called periodicity, or they adhere to what's called the periodic law. Just patterns and trends that we notice either as we move top to bottom or left to right across the periodic table. All right, in the back of the classroom are some chemistry textbooks. Okay, I want you guys to grab a textbook and turn to page 158. All right, you will notice that a majority, okay, Actually, I'm going to stop and let you guys go get a textbook. Hit pause. I think you can hit pause by hitting the space bar. I'm not sure. Give it a whirl. Okay, you've gotten your book. Now, turn to page 158. You should have a periodic table in front of you now at 158 that looks very similar to the one that's presented below. Now, what color do you see predominantly? Well, on my screen, I see pink, indicating that a majority of the elements on the periodic table are metals. All right? So the S block and the D block, and they wiggle into the P block. All right? Now, you will notice that hydrogen, go find him, atomic number 1, though he is over there in group 1, he is not a metal. He is blue on my table, right, on my screen here that you see, so he is referred to as a non-metal. All right? Now, everybody, okay, that is touching this zigzag line are these weird dudes, okay? They're not metals, they're not non-metals, they're referred to as metalloids, all right? They can exhibit properties of metals or non-metals. It just depends on the temperature conditions, on the state of matter that's present, potentially who they're trying to bond with, right? So it just depends, all right? But you'll notice that there is a giant stair step that's here. You'll see that same stair step in your textbook, all right? All right, so you know a little bit about the way the periodic table is arranged. We have groups, we have periods, we have metals, non-metals, and metalloids. All right, your job at this point, all right, is to grab your Mega Elements survey. Around the classroom, you will find some blue baskets. The blue baskets are grouped, all right, together just like groups of a periodic table. So everybody in the group 1 basket is going to be members and representative elements of the dudes in group 1, the alkali metals. So read the directions on the top of the Mega Elements handout, okay, which is attached to your notes, and begin completing a survey walk. Thanks for tuning in.